Good day, everybody. And this time around, we want to treat circle theorems. And we are beginning with the very first one that says that the angle which an arc of a circle subtends at the center of the circle is twice that which is subtends at any point on the remaining part of the circumference. The angle which an arc of a circle subtends at the center of the circle is twice that which is subtends at any point on the remaining part of the circumference. And we have three diagrams to help us prove this theorem. In this very first one, you can see that you have the arc AB subtending angle AOB at the center and angle APB at a point P on the remaining part of the circumference. The second diagram also shows angle AOB, this time reflex. It's reflex angle AOB. One is acute, one is reflex. So subtending reflex angle arc AB subtends reflex angle AOB at the center and angle APB at a point P on the remaining part of the circumference. If you look at this third diagram, it is still arc AB subtending angle AOB at the center of the circle and the angle APB at a point P on the remaining part of the circumference. We try to observe the difference in the three diagrams. Here, angle AOB at the center is acute. Here, angle AOB at the center is reflex. Here, the angle is this way, but the point P is such that when we join P to O, you see that we are getting angle APB and APO. I'm getting them in a different form from what we have in the other ones. So, in order to prove this theorem, we need construction. So we say we join PO and produce it to a point N. Join PO and produce to N. Join PO and produce to N. Join PO and produce to N. In these two diagrams, 1 and 2, you will observe that AO, of course, is equal to OB is equal to OP. AO is equal to BO is equal to PO, being the radii of the circle. Same thing here, AO, BO, PO. AO, BO, PO are equal, being the radii of the circle. Now, that makes triangle AOP an isosceles triangle and giving you the base angles equal. S1 is equal to S2. Similarly, in triangle BOP, Y1 is equal to Y2, being the base angles of the isosceles triangle. The same thing applies here. S1 is equal to S2, base angles of the isosceles triangle AOP, and Y1 is equal to Y2 for the same reason for isosceles triangle BOP. Now, as you can see here, angle AON, this angle here is the exterior angle of triangle AOP. This angle here is the exterior angle of triangle AOP. And being the exterior angle, the two interior opposite angles added up will give us that exterior angle. So exterior angle AON is equal to S1 plus S2. But instead of writing S1 plus S2, we're going to write twice S1 because S1 is equal to S2. That's why you have AON is equal to S1 plus S2 being the exterior angle of triangle AOP. And of course, it is equal to 2x1. 2x1. Since S1 is equal to x2, similarly, BON is equal to 2y1. So in both diagrams, 1 and 2, you will discover that angle AOB, reflex angle AOB is equal to angle AON plus angle BON. AON, BON. AON, BON. That's the reflex angle. Now, and so it is equal to 2s1 plus 2y1, which gives us 2s1 plus y1. But s1 plus y1, look at it. In this diagram, angle s1 plus angle y1 gives you angle APB. S1 plus y1 gives you angle APB. So, from those two diagrams, 1 and 2, we are able to prove that angle AOB, that is the angle at the center, is twice APB, the angle at a point P on the remaining part of the circumference. And if you go to the third diagram, this third diagram, you will discover that when you are talking about y1 being the base angle of a straight line BOP, you can see that your y1 contains the x1. That is, x1 is inside y1. So if we really want to get angle APB, it has to be y1 minus x1. Unlike what we observed here, we were adding the angles. But in this case, because of the nature of the diagram, because the angle S1 is inside the angle Y1, to get this angle proper, we have to subtract that angle S1 from angle Y1 in order to get angle APB. To get angle APB, it is angle Y1 minus angle X1. Now that is exactly what we have here. That angle AOB, this time AOB, angle AOB is angle AOB is angle BON, BON minus angle AON, AON, BAOB. Angle AOB is BON minus AON. That is how you get this angle AOB. Here, look at it, BON minus AON. The angle left is angle AOB. You can see that that diagram is very different from the other two. So it gives us angle BON minus angle AON. And that is the same thing as saying 2y1 minus 2x1, or 2 into y1 minus s1. I've already shown you y1 minus s1 gives you angle APB. So whichever of the three diagrams we use, we are able to prove that angle AOB is equal to angle APB. In other words, the angle which an arc of a circle subtends at the center of the circle is twice that which it subtends at any point on the remaining part of the circumference. So thank you very much. We are going to look at another theorem